Hi everyone, Joe back again for lecture 4.3, and this is for module 3 of RAD103, and we're going to start off by talking about object artifacts, which I find very fascinating because we're going to be talking about a histogram, which is really cool. Now, an object artifact happens when we have improper patient positioning, you don't have proper collimation, there is poor tube alignment with your image plate, and usually what it means is that you've selected the wrong tag for your exam, which means that you've selected the wrong histogram. So let me explain that a little bit more. All right, histogram. So let's start off by pretending we're in lab and we have to make tags for our next exam. Let's pretend we're going to be doing an elbow x-ray. So that means we have to set up our elbow exams or our elbow images in the control panel. So we go to the control panel, we hit add exam or add views. We're going to go to primary category, upper extremity, and then we're going to hit elbow, and then there's probably, you've got AP, oblique, oblique, and lateral, right? Now, there's a reason why you do that. There's a reason why you're picking specifically which views you're going to do. Each of those view tags, so AP, oblique, oblique, and lateral, not only do they automatically select your technique, it also prepares the image plate in the computer for developing that particular image. The computer program or algorithm for completing an image of an elbow or a hand is going to be very different than that of an abdomen or a chest. You know, there are different shades of contrast. There's better detail in extremity images compared to that of an abdomen image. And so the numbers or the software behind the scenes has to have an idea of what it is you're going to x-ray so that the image comes out properly. You can potentially get an object artifact by doing a hand x-ray, but you performed it under an abdomen tag. So in other words, the computer thinks that you're going to be doing an abdomen, and all of a sudden what shows up in their database are these, you know, little fine digit or these little bones of the hand, which has much different contrast associated with it. We're not going to quite get the detail that we wanted to, and so the development of that image is going to be off a little bit. So enters the histogram. So what is a histogram? A histogram is really just a chart of the different shades of gray that you have in your image. That's all it is. So this down here on the bottom is a great example of it. So this is a 256 shades of gray, which means this is an 8-bit system. So you've got all the shades of gray from black, 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 which would be 0, and number 255 would be as white as you can get, and then all of the shades of gray in between. And basically what we do is when the computer looks at an x-ray, it counts how many pixels have this 0 shade of black. You know, how many shades of this color gray, let's say that this is number, I don't know, 25. This shade called number 25, how many of the pixels in my image have that shade? And you can see it's got this many. We've got the peak here. I don't know, I'm making this up. What number is this? About roughly 100, maybe a little bit less. We'll call it 75. So shade of gray, number 75. That's where most of my shades of gray are, number 75. So again, it's just stacking up. How many shades of gray was this? How many shades of gray was this? And whatever my image is almost has no shades of white inside of it. So that is what a histogram is. So to put a definition of this, a histogram is a graphical representation plotting the number of shades of gray from black to white in an image. Okay, so why is this important? Why do we care about this? Now we care about this because, once again, the tag represents how that computer is going to develop it. And here's the thing with histograms is the histogram kind of tells us how the computer is going to handle it. And a histogram has an individual shape for each position that we select. So for example, when I look at this cervical spine, if I did 1,000 patients, and as long as my coning was correct and my positioning was correct and I looked at all of the histograms for those cervical spines for that 1,000 people, they would all have this unique shape. This is what a cervical spine histogram looks like. They all look the same. If I do an abdomen, I did 100 people, I did 100 abdomens, and I looked at all of their histograms. They're all going to have this unique shape of having this peak and that almost in the middle there. They're all going to have that. You know, once again, proper positioning, proper coning, proper technique, all of that. The shades of gray are almost always identical. Same thing for a knee x-ray. Okay, these are all the shades of gray from black to white, and this has a unique double hump shape to it. All knees are going to look the same. And so what happens is if we decide, okay, we're going to do an abdomen exam, which should look like this, but we used the cervical spine tag, this is not going to be cool with the computer. It's not going to like that. And so your shades of gray are going to be off. Your detail is going to be off. Your contrast resolution is going to be off because it's trying to do an abdomen exam under a cervical spine histogram or algorithm. And so that's why it's important that we use the right tag. Does this happen often? No. You know why? Because you're rarely adding your own exam. You know, you're rarely doing that. Usually the patient's in the system, you take the patient, you move them from Epic, and you bring them over to the modality. The modality reads Epic and says, oh, they're there for an abdomen exam, so therefore it automatically adds the abdomen tag. So we don't really have to do that. It's when we have to add a view. Let's pretend we have to do a T or we have to do a bladder shot. Then we have to add view and add the appropriate tag. That's why they break it down into primary category, secondary category, so it's hard to screw that up. But could it happen? It could happen, and it has happened in the past that we've developed the image under the wrong algorithm, and therefore the histogram doesn't have a match to it, and the development of that image is awful. Oh, I love this slide. I love this picture. I love this picture just as much as I love the picture of those knee x-rays that I've showed you a couple times. This is an example of how the computer will fix your image, whether you've overexposed it or underexposed it. So here we have the old logarithmic curve from film, so to speak, okay? And when you see this red line, the ideal shades of gray are going to fall in between something called the toe, which is kind of where this curve starts, and then you've got your straight line portion, and then you've got up here. So ideally, you want your shades of gray to be in here. This is a histogram of a chest x-ray. You're going to see this shape with chest x-rays wherever you go. So that is the shape of a histogram for a chest x-ray. And if we look at the top row, we can see that we've got an underexposure. You know, we're not really quite penetrating some of that soft tissue. The lung field is not quite as dark as we would like. And on letter C here, on the other side, we can see we've overexposed this. And again, you can see with this red line, you know, overexposure is over towards the right side, underexposure is towards the left, and you can see the histogram where it falls. If we could get that histogram to fall right in between, right where that straight line portion is, we would have the ideal shades of gray. And that's what this picture is showing you. Here we have an underexposure, okay? And what the system does, or what the computer does in the background, is it says, we are underexposed. We have too many light shades of gray here. I need all of the shades of gray to become darker. And so what do? We just take this line, or we take these shades of gray, or we take the histogram, however you want to take it, and we digitally move it to the middle. And then we get this perfect shade of gray. And so the examples that you see here on the bottom, what they're doing is they're taking those ideal shades of gray and they're moving it over the histogram to give us a better look. So here it's too white, no problem. We're going to take our ideal shades of gray, which is that straight portion of the red line, and move it to match my histogram, and we get a perfect image. Here it's already perfect. We don't need to move it. Here it's too hot. This is too overexposed. So what do? We take our perfect straight line and we move it over to match my histogram, and I've gone from overexposed to perfect image. And so that's basically what the computer's doing behind the scenes, is looking at all of those measurements of the the scintillators or whatever it is, however we're doing it, CR or DR, and we just take those shades of gray and we match it to the perfect histogram. Move it to the perfect shades of gray, and then we get the image that we need. And again, we do this because it's digital. They're just numbers, and we can change those numbers to whatever we want. And so if we just said that's too bright, darken it up, we just move this red line over, perfect. This is too dark, I need to lighten it up, take this red line, move it over, perfect. But you can see the histogram is always the same. That represents the chest x-ray. The red line represents the perfect shades of gray. You match those two up and you'll get that. All right, guys, I'm going to wrap it up here because after this we're going to jump into collimation and how collimation can screw up your histogram and cause an object artifact. So we'll do that in the next lecture. If you have any questions, let me know. Otherwise, I'll see you soon at another video. Bye.